Hello students, the title of this lesson is Solving Rational and Radical Equations. We've done a lot of talking about radicals so far in this class, but we're going to focus in specifically on solving radical equations. So our first learning target is I can solve radical equations. Our second learning target today is I can solve rational equations. So what does it mean for an equation to be rational? Well, the simplest way to explain it is an equation that is rational has a variable somewhere in a denominator. We're going to focus in on a specific type of rational equations that are very simply solved. So here we go. So first we're going to look at a radical equation. So if you look in your packet on the very front page, you'll see the picture of the puppy dog. We're going to look at the example beside of that picture. The directions say to solve. It says to solve for v, and I don't know what the worksheet was thinking, but let's just make that an a because the problem clearly has an a variable in it. Okay, and then write your answer as a decimal. So what we see is we've got the square root of a is equal to 0.6. The square root of a is equal to 0.6. And in order to get the a isolated, we need the square root sign to be canceled out. So you have to consider what is the inverse operation from taking the square root. So what would be the inverse operation for square roots? Anybody? If you said squaring, you're correct. The inverse of taking the square root would be squaring. So what we're going to do here is square this side of the equation, and when we square that side, the square gets canceled with the square root. The square root gets canceled with the square. But what I do on one side of the equation, I have to always do on the other side. So I'm also going to square the other side. That leaves me with a alone on the left side. And so now I'm just going to go to my calculator and type in 0.6 squared. And that is 0.36. We probably should have known that. 0.6 times 0.6 is 0.36. Okay? One thing I will mention about solving an equation that involves radicals. Anytime you raise both sides of an equation to a power, like we did here. We raised to the second power and raised to the second power. Anytime you raise both sides to a power, you could possibly introduce something called an extraneous solution. We've talked about that word before. Extraneous solutions are solutions that look right, and we find them, but they don't actually solve the problem. So what we really need to do to be sure our answer is correct is check it. So what is the square root of? We said a is 0.36. So we're just going to test that on our calculator. What is the square root of 0.36? If it is indeed 0.6, and it is, then we can say that this answer is correct. So when we're solving an equation that involves radicals, we're supposed to go back and check to be sure that our solution actually does solve the problem correctly. I will also add that at the very bottom of the front page, the page with this puppy dog on it, it says that there's an explanation of this problem, but there's a major typo in that explanation, so please disregard the explanation that's on the paper. You can put a big X through it if you want, but yes, there is definitely a typo at the bottom of the page, so please do not go by the explanation that is on the page. Okay, if you turn your papers back to the page that has the picture of the bat on it, then problem 1 says the square root of the quantity 2p minus 5 is equal to the square root of the quantity 3p. I will explain that when it's the square root of a quantity, the symbol could have been written as this big long square root with all of that quantity under the square root, as well as this could have been a big long square root here. Okay, so again, I've got a radical in my problem. I actually have a radical on both sides. How do I cancel a square root? And that would be by squaring. So I'm going to square both sides of the problem here, raise both sides to that second power. And it just so happens that the square root gets canceled by the square on both sides this time. So what it leaves me with is 2p minus 5 equals 3p. The square root was canceled on both sides. Now we have a simple equation to finish solving. Notice that there is a variable, 2p and 3p, on both sides of the equation. I would like to have variables on one side and my non-variable term, this one, on the other side. So let me take this 2p and I want to get rid of it from this side so that all my variables will be on this side, constants over here. So how in the world am I going to cancel the 2p? If you said additive inverse, that would be correct. The additive inverse of 2p is negative 2p. So I will just subtract 2p from both sides of the equation. That leaves me with negative 5 equals 3 minus 2 is 1p, which means p is equal to negative 5. This is my solution. But remember, this could be an extraneous solution. I do need to test it to be sure that it does make both sides equal. So in order to test that, I go back to the original problem and I'm going to replace the p with negative 5. Does that equal the other side? So let's see, what is 2 times negative 5? Well, that's negative 10, and negative 10 minus 5 is negative 15. What is 3 times negative 5? That's negative 15. Well, we've already talked about the fact that if we take the square root of a negative, that really turns that into an imaginary term. I probably don't need to go any further here because can you see that the two sides are indeed equal? Square root of 15, negative 15 is equal to the square root of negative 15. But I could write that as I radical 15 is equal to I radical 15. And since the two sides are equal, then yes, that is a true solution. So I could say yes, the solution to this radical equation is negative 5. Take a look at problem 2. This does not involve a radical. This is our second learning target. Our second learning target says I can solve a rational equation. What is it that makes this rational? Well, do you see that there's a variable in the denominator here? All it takes is a single variable in a denominator to make the equation rational. We happen to have variables in both denominators in the problem. We're going to focus in on a specific type of rational equation to solve, and that's when we have one single fraction equals another single fraction. And the best way, easiest way to approach a rational equation in which you have a single fraction equal to a single fraction is to use something that you probably learned in Algebra 1. We're going to cross multiply. So I'm going to multiply 6 times the quantity x minus 4. And I'm going to set that equal to negative 2 times the quantity, negative 2 times the quantity x plus 2. So we're using cross products here, and that is enabling us to get those variables out of the denominator of the problem. And now this is just a simple equation to solve that contains parentheses. So hopefully we remember how to remove parentheses. We use a property. What's that property called? The distributive property. That's correct. So we're going to distribute. 6 times x is 6x. 6 times negative 4 is negative 24. Equals negative 2 times x is negative 2x. Negative 2 times 2 is negative 4. And now we see this equation has variables on both sides. I would like to get rid of one, so just pick one. I'm going to get rid of this one. What is the additive inverse for negative 2x? It's positive 2x. So that means I'm adding 2x to both sides of the equation. So 6 and 2 adds to be 8x minus 24 is equal to negative 4. And now I want to use the additive inverse of negative 24 to get the constants all on the other side. So add 24 to both sides. This cancels. We've got 8x now is equal to positive 20. And last step, hopefully you know, to cancel 8 times x, we're going to use division by 8. So we divide both sides by 8. And 20 divided by 8 is the fraction, or is the decimal, 2.5, or the fraction, 5/2. So we would say that our solution, depending on how the answer choices look, is either 2.5 or 5/2. In the third example, we have another radical equation. This looks very much like the very first problem on the front page that we went through that had the picture of the puppy dog. Okay? So what I would like for you to do now is push pause on the video. I would like everyone to try to solve this equation by yourselves, and then after a moment push play and we'll see if you got it right. So pause now. So here's my work that shows that I squared both sides. The squaring cancels the square root, and I got 0.25. However, remember, with radical equations, it is possible to have something called an extraneous solution, so we do need to check to be sure that our solution works. So go back to the original problem. It says the square root of y, but I'm going to substitute y with 0.25. The square root of 0.25 equals 0.5, and I'm just going to test to see if that's true. So what is the square root of 0.25? It is indeed 0.5. So as long as that works, we can say yes, this is the true solution of the equation. So I hope this video has helped you to see that it's really not very difficult to solve equations that involve radicals or some specific types of rational equations. So our learning targets again are I can solve radical equations and I can solve rational equations. At this time, your last page of your packet has a picture of a wizard on it. There are 10 problems there that I would like for you to solve on your own. Please show all your work on your worksheet. If you need to use the back to show your work, you may do that. But you should finish that worksheet and turn that in for a grade. So do your best, and I'll see you later.